Hi, so for my Unit 3 project, I chose this problem. Log of 2 equals 1/2 log of x squared minus 6x plus 16 minus log of x minus 2. That's the original problem. So I'm going to show you each step. And before we start, I just want to tell you, for me, the easiest way to make a mistake in logs, it's not by doing something wrong. I think it might be hard to do something wrong, but it's by not knowing how to do it. Basically, there's 5 rules, and if you know those 5 rules in logs, you can't mess it up. They look intimidating at first, but it's not very hard. So for me, if you memorize the 5 laws, however many, I don't know exactly how many there are, but if you know them, it's super easy, and that's the easiest way to mess up, is by not being prepared with knowing those rules. So I'll show you how I do this and show you each step. So first, you have a negative log of x minus 2. I'm just going to add it to each side. I think it'll be easier. So we have log of 2 plus log of x minus 2 equals 1/2, yada, yada. Okay, now we're going to utilize something called the product rule. Log base a of b plus log base a of c equals log base a of bc. So if they have the same base and you're adding, you multiply the inputs. So now we turn this into log base 2 times x minus 2 equals 1/2 log, yada, yada. Okay, now I want to see if I can factor this. I think it could be easier if I was able to factor it. So I'm going to check the discriminant. 36, right? B squared minus 4ac minus 4 times 16. But that's a negative number, so we cannot factor this. And I checked that on a calculator. So we can't factor this, but that's okay. So now, next step, I'm going to see we have this 1/2 log. And you'll know the power rule, I'll explain in a sec, would make it so we can take to the 1/2 power, so the square root of x squared minus 6x plus 16. But I know because the discriminant, it'll be hard to take the square root. So instead, I'm going to multiply each side by 2. Now we have 2 log of 2x minus 4. I'll multiply this out, equals log of x squared minus 6x plus 16. This looks a lot easier to deal with. I'm going to use the power rule. So log base a of b to the c power is the same as c times the log of a to the log base a of b. So we can just move the exponent to the left, outside the log. So, or vice versa. So here, instead of 2 log of this, I'm going to say log of 2x minus 4 squared equals log of yada yada. Now we're going to use the equality rule. If log base a of b equals log base a of c, b equals c. That's pretty straightforward. In other words, we're base 10ing each side. We're saying 10 to this equals 10 to this. So we're getting rid of the exponent, getting rid of the logs. So 2x minus 4 squared equals x squared minus 6x plus 16. I'm going to multiply this out. 4x squared minus 16x plus 16, right? A plus b squared equals a squared plus 2ab plus b squared, right? Pretty straightforward. So 4x squared minus 16x plus 16 equals x squared minus 6x plus 16. I'm going to take out, you can see each step, I do one at a time, but I get 3x squared minus 10x equals 0 if I put it all on one side. But I can factor out an x. So I have x times 3x minus 10 equals 0. Okay, so we know x equals 0 or 3x minus 10 equals 0. I do the math. So x equals 0 or x equals 10/3. That seems like a good answer, but we need to check our work, right? So first of all, I'm going to check x equals 0. Log of 2 equals 1/2 log of 16, right? 0 squared minus 6 times 0 just plus 16, just 16, minus log of 0 minus 2, or log of negative 2. That answer does not work. We can have no negative inputs to logs, like I wrote here. So that one doesn't work. Let's try x equals 10/3. Log of 2 equals 1/2 log of 10/3 squared minus 6 times 10/3 plus 16, minus log of 10/3 minus 2. I could do this with fractions, do a lot of math, but I just did it in decimals. I got log of 2 equals 1/2 log of 7.11 bar minus log of 1.33 bar. So 4/3. I did it in a calculator. But then I'm going to do the same thing. I'm going to add log of 1.33. So we have log of 2 plus log 1.33 is 1/2 log of 7.11. Log of 2.66, right, multiplying in sides, equals log of root of 11, right, 711, because 711 to the 1/2 power. And I put in a calculator, the root of 7.11 is 2.66. So 10/3 is the correct answer. I also checked my work on Desmos. I plugged in the equation and I gave the variable a, and then I set a to 0, and log base 2 is this, but this answer is undefined because we have the a minus 2. That doesn't work. But now I did it with b, a new variable. B equals 10/3, and log of 2 is 0.301, and this becomes 0.301. So that's correct. Okay. Now I'm gonna and the other thing that I think you can get stuck on, other than just not being prepared with the rules, is knowing that you need to add. Because, and I'll show you in my extra problem, it'll be even harder. But in this case, right, I added log of x minus 2 to each side, which made it a lot easier. Say I didn't add it and I just had log of 2, and then say I multiplied everything by 2 still, so I can get rid of the 1/2. So I have 2 log of 2 equals log of x squared minus 6x plus 16 minus log of x minus 2. Then I would have to do x squared minus 6x plus 16 divided by x minus 2, which would be a lot more work. So it's easier. You just need to know you can add. That's the biggest thing I could think you could mess up on. Okay, harder problem. So I kept the same problem and I just added another piece to each side. Now we have negative, and I'm not going to go by how I did each step, but you'll know, because now I just taught you the properties. Negative log of 2 plus log of 4x minus 8 equals 1/2 log of this, same thing, plus log of x minus 2 instead of minus, and then minus 1/4 log of x squared plus 8x plus 16. This one's a little more fun, huh? Okay, first I'm just going to rearrange this to make it seem easier. Log of 4x minus 8 minus log of 2. I flip them around, equals 1/2 log of x squared minus 6x plus 16, same thing, plus log of x minus 2, same thing. But here I have minus 1/4 log of x squared plus 4x plus 16, right? Instead of plus 8x, I did plus 4x plus 4x. I'm going to try to see if I can do grouping. It looks like I could do grouping to factor that. Okay, now we divide, right? That's how you subtract logs. Log of 4x minus 8 over 2. And now I'm going to take away log of x minus 2 from each side. So minus log of x minus 2 equals 1/2 log. This is the same thing. Minus 1/4 log, right? We have x times x plus 4 plus 4 times x plus 4. See how I'm grouping that? And because I think we're going to get something nice over there. Okay, I'm going to divide these out. So log of 2x minus 4 minus log of x minus 2 equals 1/2 log. That's the same thing. Minus 1/4 log of x plus 4 times x plus 4. That looks pretty nice. And if you multiply it out, x plus 4 times x plus 4 equals this. Okay. Now, I'm going to divide again, right? 2x minus 4 over x minus 2. So log of that equals 1/2 log of this is the same thing. But now we have minus 1/4 log of x plus 4 squared, right? X plus 4 times x plus 4. Okay. Now, we're going to say, I'm going to multiply everything by 2 to get rid of this 1/2. So we're going to have 2 log, and then I rewrote this, so instead of 2x minus 4 over x minus 2, it's 2 times x minus 2 over x minus 2. If you multiply that out, you'll see it's the same. And that helps me figure out how to divide. So 2 log of that equals the log of x squared minus 6x plus 16. I got rid of the 1/2. Minus 1/2, right, 2/4, but minus 1/2 log of x plus 4 squared. Okay, now I divide this out, so I get 2 log of 2 equals log of this minus log of x plus 4. If you have 1/2 times the square, they cancel each other out, because I can move this square to the front and it'll cancel out. Okay, so now I have log of 2 squared, and now I'm going to add log of x plus 4 to each side. I think it'll be easier again. It's going to be really hard to divide those. So I'm going to log of 2 squared plus log of x plus 4 equals log of x squared minus 6x plus 16. Okay. Now, 2 squared is 4, right? So I'm going to multiply again. So log of 4 times x plus 4, multiplying the inputs, equals log of x squared minus 6x plus 16. Okay, equality rule, right? 10 to the power of each side, base 10. So we have 4x plus 16. I multiply those out, equals x squared minus 6x plus 16. I do the math. I get x squared minus 10x equals 0, or x times x minus 10 equals 0. So x equals 0 or x equals 10. Okay, let's check our work one last time, huh? So first I do x equals 0. I'm not going to rewrite the whole problem, but we see one of our components here was log of x minus 2. If x equals 0, we have log of negative 2. Again, no bueno. That does not work. So that is not a rational number. So x equals 0 does not work. But what about x equals 10? Okay. I have log. So I kind of skipped. I went to this step because I didn't want to do from the very beginning. But I have log of 40 minus 8, right? 4 times 10 minus 8 over 2 equals 1/2 log of 100, 10 squared, minus 60 plus 16, minus 1/4 log of 100, right? Plus 80 plus 16. 100 plus 8, 10 times 10 plus 8 times 10 plus 16. Okay, I do the math. I get log of 32 over 2 equals 1/2 log of 56 plus log of 8 minus 1/4 log of 196. Okay, I did that in a calculator. Okay, so now I'm going to multiply each side by 2 to get rid of the 1/2 log. So we have 2 log of 16 equals log of 56 plus 2 log of 8 minus 1/2 log of 196. Okay, now I'm going to use the power rule. So log of 16 squared equals log of 56 plus log of 8 squared minus log of the square root of 196. I rewrote to the 1/2 power. And then log of 256, 16 squared is 256, equals log of 56 plus log of 64, that's 8 squared, minus log of 14. The square root of 196 is 14. So now, log of 256 equals log of 56 times 64, but then divide that by 14, because that's, you multiply and divide for subtraction. And then I did the math in a calculator, and that's 256 equals 256. So x equals 10 works. And again, I did it in Desmos to show you. I wrote the two sides of the equation. I said a equals 0, and they were both undefined. But then I did again, b equals 10. I did it in b. And now 1.204 and 1.204, they're equal to each other. So, thank you for watching. I hope this clears up some questions you had about logs, how to deal with them. You just got to remember your fundamental, your rules, and remember it's like nearly impossible to divide these polynomials, so instead you add one to the other side. It's easier to multiply polynomials. So that's the harder parts, and I hope you could see how it's more complicated, and thank you for watching.